Hi everyone, myself Vijay Kumar. I am 2-year MSc student at IIT Kharagpur. In today's class, I will teach about dimension analysis. So first of all, let us see what will we cover in this topic. So we will see what is dimension analysis, and mostly we will see how powerful tool is this, because using this we can check validity of any equation. Means if any equation is written there, is that is right or wrong. For example, like we all know our famous equation v is equal to u plus at, but if I am saying it is at square, so how will you contradict this, that no, this is at square is wrong, at is the right thing, so this equation is wrong. So we will check this using the dimension analysis. We can derive new formulas also, like as how this is 80 not 80 square. So using this concept dimension analysis, we can derive new formulas. So mostly we will see about this thing. So first I will start with dimension analysis, then we will learn how to write the dimension of different physical quantities, and then these two things. So let's start here. So as we all know, we have 7 fundamental quantities. So here are the 7 fundamental physical quantities. This is its SI unit and this is its dimension. So it is a convention that whenever you have to write a dimension, we will write this in a square bracket. So for mass, the SI unit is kg. We write that using the capital M. Length, its SI unit is meter. We write this as capital L. L is coming from here, length. Similarly, time, second, T. Temperature, Kelvin, but T is already engaged here, so we will use theta. Then luminous intensity, SI unit is candela, and we use the same, this CD we use here. Similarly, electric current, SI unit is A, we will use the same, and amount of substance, mole, we will use the same. So let's see how will we write. These are the fundamental quantities. How will we write the dimension of some derived physical quantity, not the fundamental quantity. The best example is, suppose we have acceleration. But before acceleration, let's see, we have velocity. So we all know velocity is displacement by time. So velocity is displacement by time. So what is displacement? Displacement is length and time is time. So displacement is a length, and if we have to write the dimension of velocity, so how will we write? Dimension of velocity will be length, that is L, and this is time, so it is T. So if this will go up, we will write this as LT minus 2, sorry, LT minus 1. So this is the dimension of velocity. Similarly, a speed will have the same velocity, same dimension. But if we say acceleration, so acceleration is rate of change of velocity. From this approach we can also come, but I am coming from different approach. We know that SI unit of acceleration is meter per second square. So if we know the unit, by that approach also we can derive the dimension. So this is meter. Meter means what? Length. So for length we will write L. Per second square means it is in denominator, so it is time square. So it will go up, it will be LT minus 2. So this is the dimension of acceleration. From using this we can derive the another one, like for example we can take for force. So what is force? Force is mass into acceleration. Don't confuse this M with this. This is the unit. This is the meter. This is meter and this is the mass. Force is equal to ma, second law, Newton's second law. So mass into acceleration. So if we have to write the dimension of force, the dimension of mass is, so dimension of mass is, watch here, dimension of mass is m. So it is m here. And dimension of acceleration we have already derived, it is LT minus 2. So this will be LT minus 2. So our dimension will be MLT minus 2. So this is the dimension of force. Since we know the dimension of force, we can proceed further. For example, if we have to find the dimension of work, so work is what? Force into displacement. So force unit we know. Force is what? MLT minus 2, and displacement is L, because it is a length. So we can write this as ML square T minus 2. So by this way we can write the dimension of any physical quantity. So work we write in the term of basic fundamental quantity. What this is showing? It is showing the work is given as 1 times mass length square divided by 10 to the power minus 2. It is equivalent to joule, 1 joule. So these are the things. How will we write the dimension of different physical quantity? I hope we all know this. So now I am erasing this also. And let's see what are the applications of dimension analysis. So the first application will be checking the validity of equation. So we can check that any equation is dimensionally correct or not. The main advantage is with this thing is that we can check the equation is wrong. But if it is coming right, we cannot say the equation is right. Why? Let's see. The fundamental concept behind this is that if we have a physical quantity A which is equal to B plus C or minus C in both cases, so whenever we are adding or subtracting any quantity, the physical dimension or dimension of these all quantity must be same. Means dimension of A should be equal to dimension of B should be equal to dimension of C. If any of them are not equal, this equation will be wrong. So if all three dimensions are matching, then okay, this equation is right. If any one of this is not matching, two are matching, this is not matching, so equation will be wrong. So if equation will be wrong, then okay, it is wrong. But if it is right, we cannot say it is right, totally right. Why? What? If I multiply here with 2, so it is not going to affect the dimension of B. So dimensionally correct means I am writing 2 also. In that case also it is dimensionally correct. So due to the prefactors, the equation may be wrong. Like as, let's see one example, then I will come back here. I am writing an equation that V is equal to U plus AT square. So we know this is wrong. How will you say this is wrong? Watch here. V is velocity. Just few times ago we calculated this. Velocity is what? Meter per second. So LT minus 1. U is also velocity. It is LT minus 1. Acceleration we have calculated. LT minus 2. And T square I have written. T square. So what are we getting? This is okay. This is okay. LT minus 1. But what is the problem with this? If you do this, this will be just come L. But what should it become? LT minus 2. LT minus 1. Because this is LT minus 1. So this is coming LT minus nothing. L, just L. So we can say no, this equation is wrong because this has not the same dimension of this. And it is demanding that it should be minus 1. Means this should be 1. Then we will get LT minus 1. So it is saying that it is wrong. So if dimensionally it is wrong, then it is totally wrong. But if I write the right equation, V is equal to U plus AT, in that case the dimension will match. But if I say 2AT, in that case also dimension will match. So V is equal to U plus AT is a correct equation, dimensionally correct, but V is equal to U plus 2AT is also dimensionally correct. So we cannot say that dimensionally right equation is right. If dimensionally wrong, we can say it wrong. So using the dimension analysis, we can check that any equation is right or wrong. If it is wrong, it is totally wrong. If it is right, not need to be right because the prefactors may affect the equation. I hope this point you understood what is going here. Then we will come on the second one. The second application is that we can derive relation between different physical quantities. Fundamental concept will remain same, that we can only equate or add or subtract only those quantities which are equal. So it means if there are various physical quantities like A is equal to B, C, D, it depends upon three factors. So dimension of A should match the dimension of this. And if it is not matching, we will take power A, B and C, write the dimension of right hand side, equate that with left hand side, and then we will find the value of A, B, C such that the dimension will match. We will take one example, very good example. A simple simple pendulum having mass m, length L, and suppose acceleration due to gravity is g. We know somehow that time period will depend upon some physical quantities like length, mass and acceleration due to gravity. But how will it depend? We don't know. We don't know what is the relation between this. So suppose this is depend as A, this depend as B, this depend as C. And since we are equating, so dimension of both sides must be equal. So this is time period, so its dimension will be T. This is mass, so its dimension will be M to the power A. This is length, so it will be L to the power B. And this is acceleration, so it will be LT minus 2 to the power C. If we equate this one, so it is M to the power A, L to the power B plus C and T to the power minus 2C. And if you compare the left hand side, we have M to the power 0, L to the power 0, T. So if we compare this, so A will be equal to 0, B plus C will be equal to 0 and minus 2C will be equal to 1. So C will be minus 1 by 2 and if you plug this back, B will be 1 by 2. So what we are getting? T is equal to mass to the power 0, length to the power 1 by 2 and g to the power minus 1 by 2. It means time period will be independent of mass, will depend upon root under L by g. So dimensionally we are getting this relation. This is slightly correct, not totally correct, partially correct, because there is a prefactor here that cannot be determined using the dimension analysis as I discussed here, that this will be anything, but it is giving more or less the same result which we are expecting. So this is all for today in dimension analysis. Hope you enjoyed this lecture. See you in next class. Thank you.